This is the next video in section 1-4. I am on page 2, and we are looking at a series of chemical reactions here. There are a lot of them. I'm going to look at maybe half of them. So you have a reaction, then you have the type of reaction, and then the question, is it redox? So for each one of these, we can look at the type of reaction, and we can figure out its type based on the structure. So in this top one, we have one reactant turning into two products. The structure of this reaction tells us that it is decomposition. The question of is it redox is a little more complicated. We can't tell just by looking at the structure. Sometimes we can, most of the time we can't. What we have to do is look at the oxidation states or the oxidation numbers of each one of these individual substances. So starting with silver oxide. So I know that oxygen is pretty much always -2 in its oxidation state. In order for this to be a neutral compound, there would need to be a total of +2 over here. There are two silvers, and that means each one of them has an oxidation state of +1. Silver solid, that's an element all by itself in its natural state. The oxidation state is 0. Same thing with O2 gas, that's oxidation state is 0. Those are its elemental forms. So the question of is it redox can be answered by asking, does the oxidation number of the elements change? For instance, silver goes from a +1 to a 0. Is it redox? Yes, the oxidation numbers are changing. Same thing with oxygen. It has a oxidation state of -2, and then when we see it again, it has an oxidation state of 0. In this next reaction, this is B on your list, we have two aqueous compounds making a precipitate and another aqueous compound. So this, we have an ionic compound. This is a double replacement reaction. Double replacement. So on the question of is this redox, we have to look at the oxidation numbers. So when we're talking about an ion, its oxidation number is its charge. So if we look here, this is nitrate, NO3. All of this together has a -1 charge, which means that silver has to have a +1 charge or a +1 oxidation number. Oxygen is -2. So all of this nitrate is -1. So let's look at the total for oxygen is -6. If we want it to be -1, nitrogen has to be +5. And when we label the oxidation numbers, we want to talk about individual atoms of the element. We do not want to talk about all three of them at once. So this is just me showing my work. These are the actual oxidation states of each element. For the next one, potassium is an alkali metal. It has a charge of +1. Its oxidation state is +1. Oxygen is -2. 4 of them would make all of that -8. The charge of this chromate is -2. And I know that because there are 2 potassiums, this is overall a +2. So for this ion, we need to know chromate minus 8 is going to equal -2. So what is the oxidation state of Cr, chromium? This would need to be +6. +6 minus 8 is -2. There is its oxidation number. As we move along, we see silver, and now it's Ag2CrO4. The charge of this silver didn't change. The charge of the chromate didn't change, which means that the oxidation states of chromium and oxygen did not change either. Potassium, still an alkali metal, still +1. This is still nitrate. And so as we look at this, none of the oxidation numbers changed in this reaction. So the question of, is this redox? No, because the oxidation numbers did not change. In this next reaction, this is part C. We have some sort of a carbon, hydrocarbon. This is actually an alcohol, methanol. Plus oxygen gives us CO2 and H2O. This, just looking at structure, is combustion. Is it redox? That requires us to look at the oxidation numbers. So, let's take a look. These out of the way. Okay, so oxygen, as we know, is always -2. Hydrogen is always +1. The charge of hydroxide is -1, so that works out. Here we have CH3. Hydrogen is always +1. Carbon is kind of the tricky one. So what we have here, we have a negatively charged OH, and this CH3 is going to be CH3 with a +1 charge. So we've got, this is the total of hydrogens. This is the total charge of the ion. And so carbon must be -2. Oxidation number of -2. Then we have oxygen gas. This is the elemental form. Oxidation number is 0. Plus 2 carbon dioxides. So each oxygen is -2. That would be a total of -4, which means our carbon has to be +4. And then H2O, oxygens are -2, each hydrogen is +1. And these are the oxidation numbers. So is this redox? Well, let's look at the oxidation numbers. Carbon changes from -2 to +4. If the oxidation number of an element changes, yes, it is redox. Hydrogens were always 1. Oxygen, -2, -2, -2, but here's 0. So oxygen's oxidation number also changed, in some cases, not all of them. Next up, we have this one. We have one reactant and becoming 2 products. This one is decomposition. Is this one redox? Let's look at the oxidation numbers. Oxygen is -2. That makes mercury +2. Here, mercury is by itself. That's 0. Oxygen's elemental form. That's 0. Is this redox? Yes, it is. In the next one, we have iron in its elemental state, oxygen in its elemental state, both with oxidation numbers of 0. Then we have iron 3 oxide. So the oxygen is -2, the iron is +3, and so we have redox, yes. And this one, the type, we have two reactants becoming one product. This is a synthesis reaction. Skipping down to L, so in this one we have magnesium plus 2HCl. Magnesium in its elemental form, that's 0. We have chlorine, which has a charge of -1. That's its oxidation number. Hydrogen plus 1. Hydrogen gas is in its elemental form, that's 0. And over here we have chloride, -1 oxidation state, and magnesium with a +2. So is this one redox? Yes. Hydrogen is changing and magnesium is changing. Yes. This reaction is a single replacement where we have an element and a compound making a different element in a different compound. The last one for now is M. We have MgCO3 yielding MgO and CO2. First off, we have one reactant making two products. That is decomposition. And if you look back, so far every decomposition reaction has been redox. But let's look at the oxidation numbers just to be sure. So here we have CO3. All of this has a -2 charge. So oxygens are -2. 3 oxygens is going to make that a -6. The charge of carbonate is -2, so we have to have a carbon for something that gives us -2, and that would be +4. And then magnesium, not 2 plus, it is +2. With oxidation states, the positive or the negative comes first and then the number. In the products, we have oxygen, which is -2, magnesium ion, which is +2. We have oxygens, which are each -2, which means this carbon needs to be a +4. Is this one redox? Magnesium stays the same, carbon stays the same, oxygen stays the same. No. So this one is not redox. Looking down just a little bit, we have always, sometimes, and never. So always, sometimes, and never. Two types of reactions that are always redox. First off is single replacement. The element always has an oxidation state of 0 in the reactants, and then it's going to be in a compound, which means its oxidation number has to change. Combustion is always redox. Never. So we have one type that is never redox, and that is double replacement. Because these are ions, the ions never change their charges in a double replacement, and that means the oxidation numbers never change. So that one is never. Sometimes redox, this would be synthesis. it is redox sometimes, other times it is not. Decomposition, as we saw in the examples, sometimes it is, sometimes it's not.